Hello, in this lecture we will find out the radius of the biggest circle. In the drawing we have 4 circles. These 3 circles is inside the biggest circle. We know that the radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, the radius of the smallest circle is equal to 1 unit, and we want to find out the radius of the biggest circle. Okay, so first of all I will explain to you 2 new terms. Actually, when 2 circles are touching each other, or when 2 circles are tangent to each other, then there are two types of tangency. The first type of tangency is an external lunge. Here those 2 circles are touching each other at point S. S is the point of tangency of those 2 circles, and the distance OM, actually M is the center of this circle and O is the center of the bigger circle. Capital R is the radius of this circle and small r is the radius of this circle. And OM, that is actually the distance between the centers of those 2 circles, is equal to the sum of the lengths of the radiuses, that is to say, it will be equal to capital R plus small r. Okay, so whenever 2 circles touching each other externally, like in this drawing, then the distance between their centers, in this case it is MO, will be equal to the sum of the lengths of the radiuses, that is to say, in this case it will be equal to capital R plus small r. Okay, so, and we also have second type of tangency between 2 circles. The second type of tangency is an internal lunge. Like in this drawing, those 2 circles are touching each other internally at point S, and here the distance between the centers of those 2 circles, that is to say OM is equal to the difference between the lengths of the radiuses, that is to say, the distance between the centers of those 2 circles will be equal to capital R minus small r. And you can see here, it is very easy to see it. Here we know that OS equals to capital R, SM equals to small r. Therefore, OM, that equals to OS minus MS, must be equal to capital R minus small r. So, whenever you have an internal line between 2 circles, that is to say that they are touching each other internally, like in this drawing, then the distance between the centers of those 2 circles will be equal to the difference between the lengths of their radiuses, that is to say, it will be equal to, in this case, capital R minus small r. Okay, so here we have We will define the center of this circle. This point is point A. We will define the center of this circle as point B, and we will define the center of this circle as point C. Okay, and we will define the center of the biggest circle as point O. And we have here a straight line that is actually tangent to this circle at this point. We define the point of tendency of the straight line with this circle as point D. Again, point D is the point of tendency of this straight line with this circle. We will define the point of tendency of the straight line with this circle as point E, and we will define the point of tendency of the smallest circle with this straight line as point F. And here we will join points A and D together by a straight line. Here, line segment AD is the radius of this circle because of the fact that it starts from point A, that is the center of this circle, and ends at point D, that is the point on this circle itself. Therefore, AD is the radius of this circle, that is to say, it equals to 4 units. And we'll join points B and D together by a straight line. So here BE is the radius of this circle for the same reason, because of the fact that it starts from the center of the circle and ends at point E, that is a point on this circle itself. Therefore, BE is the radius of this circle, that is to say, it equals to 9 units. So I write here that BE equals to 9 units. And we will join points C and F together by a straight line. Here, CF is the radius of the smallest circle, that is to say, it equals to 1 unit. So here, CF equals to 1 unit. So in the next step, I will present to you a new rule. Rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I'll read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So here we have the radius AD. The radius AD of this circle is drawn to the point of tangency. That is to say, it is drawn to point D, that is the point of tangency of this straight line with this circle. Therefore, according to rule number 1, this tangent will be perpendicular to the radius AD. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, here we have the radius BE that equals to 9 units. The radius BE is drawn to the point of tangency, that is to say, it is drawn to point E, that is the point of tangency of this tangent with this circle. Therefore, according to rule number 1, this tangent will be perpendicular to the radius EV, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius CF that is drawn to the point of tangency. That is to say, it is drawn to point F, that is the point of tangency of this tangent with the small circle. Therefore, this tangent will be perpendicular to the radius CF. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? So, in the next step, we will draw perpendicular from point O to DE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point of the perpendicular from point O and DE as point M, SM. And in the next step, we will draw perpendicular from point A to BE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point of the perpendicular from point A and BE is point P, and here if we focus on the quadrilateral APDE, in quadrilateral APDE, we have three right angles, 1, 2, 3, and the sum of three right angles is 90 times 3 is equal to 270 degrees, plus the size of this angle, that is actually angle DAO or DAP. The sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So we get that 270 degrees plus the size of angle DAP must be equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that angle DAP equals to 360 degrees minus 270 degrees is 90 degrees. So angle DAP is a right angle, it equals to 90 degrees. So you can write here that this angle is a right angle, it equals to 90 degrees. And therefore quadrilateral ADEP, quadrilateral ADEP has four right angles, and therefore quadrilateral ADEP is a rectangle. Okay, quadrilateral ADEP is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to PE, AD equals to PE, but we know that AD equals to 4 units, AD equals to 4 units, so from this equation AD equals to PE equals to 4 units, we will derive that PE also equals to 4 units. So here PE equals to 4 units. And here the sum of the angles in this quadrilateral, we define this point S, and we know that the sum of the angles in quadrilateral ADMS, the sum of the angles must be equal to 360 degrees, and we have 1, 2, 3 right angles. So the sum of the 3 right angles is 270 degrees. In quadrilateral ASDM, the sum of the angles must be equal to 360 degrees. So we have 3 right angles. The sum of 3 right angles is 270 degrees, plus angle ASM, plus angle ASM. In total, the sum of those 4 angles must be equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that angle ASM equals to 90 degrees. So here angle ASM equals to 90 degrees. This is a right angle. And we know that OM is perpendicular to DE, therefore OM is a straight line. Okay, OM is a straight line. OM is a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line OM at point S, the sum of the angles must be equal to 180 degrees. So this angle is 90 degrees, plus the size of this angle, that is actually angle OSA. In total, the sum of those 2 angles must be equal to 180 degrees. So here 90 degrees plus the size of angle OSA. In total, the sum of those 2 angles must be equal to 180 degrees. Here we'll subtract 90 degrees from this equation, and we will get that angle OSA equals to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that this angle is a right angle, it equals to 90 degrees. And here quadrilateral SPME, quadrilateral SPME, this quadrilateral has 3 right angles, and according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, we get that 270 degrees, it has 3 right angles, so 1, 2, 3. The sum of 3 right angles is 270 degrees, plus the size of this angle, that is actually angle MSP. In total, the sum of those 4 angles must be equal to 360 degrees. We subtract 270 degrees from this equation, and we'll get that angle MSP equals to 90 degrees. So angle MSP equals to 90 degrees. This is a right angle. Therefore, quadrilateral SPME is a rectangle because of the fact that it has 4 right angles. So that is to say, PE is equal to SM, according to the rule that the opposite sides of a rectangle are equal to each other. We get that PE equals to SM. PE equals to SM. But PE, we already found out that PE equals to 4 units. So from this equation, 4 equals to PE equals to SM. We will get that SM also equals to 4 units. SM equals to 4 units. So here we can write down that SM equals to 4 units. And we know that BE equals to 9 units. It is the radius of this circle. And PE equals to 4 units. So BP will be equal to BE minus PE again. BP will be equal to BE minus PE. I'll write it down. Here BP, its line segment will be equal to BE minus PE. Again, BP equals to BE minus PE. So BP equals to BE, that is 9 units, minus PE, that is 4 units. So BP equals to 9 minus 4 is 5. So we found out that BP equals to 5 units. Here BP equals to 5 units. In the next step, we'll join points A and B together by a straight line. So we know that BP equals to 5 units. And what is the value of AB? A is the center of this circle and B is the center of this circle. And those two circles have an external notch between them, that is to say, they are touching each other at this point externally. Therefore, AB, that is the distance between their centers, will be equal to the sum of the lengths of their radiuses. The length of this radius is 4 units, the length of this radius is 9 units, so 4 plus 9 will be equal to AB. So here AB equals to 4 plus 9. 4 plus 9 is 13. So we found out that AB equals to 13 units. We know that BP equals to 5 units. So we will focus on the right triangle, triangle ABP. On the right triangle, triangle ABP, according to the Pythagoras theorem, and then in the right triangle, triangle ABP, by PT is the abbreviation for Pythagoras theorem. The square of the hypotenuse, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BP square plus AP square. I'll repeat again. In the right triangle, triangle ABP, according to the Pythagoras theorem, AB square, that is the square of the hypotenuse, equals to BP square plus AP square. We have already found out that AB equals to 13 units, so AB square is 13 square. 13 square is 169. 169 equals to BP square. BP equals to 5, so BP square is 5 square. 5 square is 25 plus AP square. AP is the missing variable, so we will leave it as it is. So in conclusion, we found out that 169 equals to 25 plus AP square. We will subtract 25 from this equation, and we will find out here that 169 minus 25 is 144 equals to AP square. Here we will take a root out of this equation, and we will get that AP equals to the square root of 144, and the square root of 144 is 12. So we actually found out that AP equals to 12 units. So we can write here that AP equals to 12 units. But we also know that quadrilateral APDE is a rectangle because it has 4 right angles, and the opposite sides of a rectangle are equal to each other. So I write it down. APDE is a rectangle. Quadrilateral APDE is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AP equals to DE. AP equals to DE. But we just right now found out that AP equals to 12 units. So can I write here that AP equals to 12 units, And from this equation, DE equals to AP equals to 12, we will derive that DE also equals to 12 units. So we can write here that DE equals to 12 units. So as you can see here, all the quadrilateral are rectangles because all of them have 4 right angles. So here, if we define ME as x, that is to say ME equals to x according to our definition, then dm will be equal to DE minus ME. Again, dm will be equal to DE minus ME. I write it down. dm will be equal to DE minus ME. dm will be equal to DE minus ME. So dm will be equal to DE, that is 12 units, minus dm, that is x. So in conclusion, we found out that dm equals to 12 minus x. dm equals to 12 minus x. And because of the fact that quadrilateral ASMD has 4 right angles, it is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, DM equals to AS. In rectangle AS DM in rectangle ASDM, the opposite sides are equal to each other. That is to say, DM equals to AS. DM equals to AS. But we found out that DM equals to 12 minus x. dm equals to 12 minus x. So from this equation, dm equals to as equals to 12 minus x, we will derive that as also equals to 12 minus x. So we can write here that dm, the as also equals to 12 minus x. Likewise, in rectangle SPME, ME equals to SP. I'll write it down. In rectangle MESP, we know that ME equals to SP, according to the rule that the opposite sides of a rectangle are equal to each other. I'll repeat again. In rectangle MESP, ME equals to SP. But according to our definition, ME equals to X. ME equals to X according to our definition, and from this equation X equals to ME equals to SP, we will derive, we will conclude that SP equals to also X. So here SP equals to x, and here we will define OM as y. OM equals to y according to our definition. So we can write here that OM equals to y according to our definition. So what is the value of OS? The value of line segment OS, it will be equal to OM minus SM. OS equals to OM minus SM. Again, OS equals to OM minus SM. So OS will be equal to OM, that is equal to y according to our definition, minus SM, that is equal to 4. So in conclusion, we found out that OS equals to y minus 4. So we can write here that OS equals to y minus 4. And what is the value of AO? The value of AO A is the center of this circle, that is radius is equal to 4 units. O is the center of the biggest circle, that is radius is equal to capital R. And the biggest circle and this circle have an internal lunge between them at this point. Therefore, the distance between their centers, that is to say AO, will be equal to the difference between the lengths of the radiuses. That is to say, it will be equal to capital R minus 4. AO equals to capital R minus 4. So here, in the next step, we will focus on the right triangle, triangle AOS. So I will copy again the right triangle, triangle AOS. And we will implement the Pythagoras theorem on the right triangle, triangle AOS. So this is the right triangle AOS in the green color. We will implement the Pythagoras theorem on this triangle AOS. So in the right triangle AOS, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AO, so the square of the hypotenuse is AO squared, and it will be equal to OS squared plus AS squared. So according to equation number 1, AO equals to R plus 1, so AO squared is R plus 1. It is actually AO equals to R minus 4. So AO squared will be equal to R minus 4 squared. And it equals to OS squared. OS is y minus 4, so OS squared will be equal to y minus 4 squared plus AS squared. AS is 12 minus x, so AS squared is 12 minus x squared. Okay. So here we will open the brackets on both sides of this equation number 1. R minus 4 squared is R squared plus 16 minus 8R. That equals to y minus 4 squared. Y minus 4 squared is equal to y squared plus 16 minus 8y plus 12 minus x squared is equal to 144 plus x squared minus 24x Here we have 16 on both sides of equation number 1, so 16 will get cancelled. We will add 8r to this equation number 1, and we will get that r squared equals to 8r minus 8y plus 144 minus 24x plus x squared plus y squared. Here we will add x squared and also y squared to this equation number 1, and we will get that according to equation number 1, r squared minus x squared minus y squared here will be equal to, here we have 8r minus 8y. We take 8 as a common factor of those two expressions, and inside the brackets we will have r minus y plus 144 minus 24x. So according to equation number 1, r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. Okay? In the next step, we will draw perpendicular from point O to BE. So here, so this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point between the perpendicular from points A and BE as point T. And we'll focus on the right triangle OBT. But before that, quadrilateral OSPT here actually quadrilateral MEOT has 3 right angles. Any quadrilateral that has 3 right angles the fourth angle must be also equal to 90 degrees. That is to say, this angle must be also equal to 90 degrees. So this angle is a right angle, and so quadrilateral OTPS has 3 right angles, therefore the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. It means that if quadrilateral has 3 right angles, the fourth angle must complete the sum of the angles to 360 degrees, therefore it must be equal to 90 degrees also. So we found out that quadrilateral OTPS has 4 right angles. Any quadrilateral that has 4 right angles is a rectangle. So the rectangle OTSP rectangle OTSP, we know that SP equals to OT, according to the rule that the opposite sides of a rectangle are equal to each other. SP must be equal to OT, but SP equals to X. We already found out that SP equals to X. Therefore, from this equation, X equals to SP equals to OT, we will derive, we will conclude that OT also equals to X. So here, OT equals to X. And what is the value of BT? The value of BT, these 9 segments, it will be equal to BE minus TE. Okay, and write it down. BT will be equal to BE minus TE. Again, BT here, BT must be equal to BE minus TE. But we have already found out that quadrilateral OTME is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say, OM equals to TE, OM equals to TE, in rectangle OTME OM equals to TE. But OM equals to Y according to our definition. OM equals to Y, so from this equation Y equals to OM equals to TE, we derive that TE also equals to Y. TE also equals to Y. Here TE equals to Y. TE equals to Y. So what is the value of BT? We already found out that BT equals to BE minus TE. So BT equals to BE, that is the radius of this circle, that is to say it equals to 9 units, minus TE. We just right now found out that TE equals to Y. So in conclusion, we found out that BT equals to 9 minus Y. BT equals to 9 minus Y. Here BT equals to 9 minus Y. And T equals to X. And what is the value of OB? The value of OB is actually O is the radius, O is the center of the biggest circle, that its radius is capital R, and B is the radius of this circle, that its radius is 9. So in conclusion, we will conclude that OB it is the distance between two circles, the centers of two circles that have an internal length between them. The biggest circle and this circle are touching each other at this point, so the distance between their centers will be equal to the difference between the lengths of their radiuses. That is to say, it will be equal to R minus 9, capital R minus 9. So we will focus on the right triangle OBT. So I will copy the right triangle OBT again in a new page. So this is the right triangle OBT. Triangle in the green color is triangle OBT, the right triangle. We will implement the Pythagoras theorem in the green right triangle, triangle OBT. According to the Pythagoras theorem, in the right triangle, triangle OBT, the square of the hypotenuse equals to the sum of the squares from the perpendiculars. That is to say, here is actually point B. This point is point B, and this is triangle OBT. So according to the Pythagoras theorem, in the right triangle, triangle OBT, OB square equals to OT square plus BT square. That is to say, R minus 9 square equals to 9 minus Y square. Nine minus Y square plus OT square. OT is X, so OT square is X square. So here we will open the brackets on both sides of equation number 2, and we will get that R minus 9 square is R square plus 81 minus 18R, that equals to 9 minus Y square. 9 minus Y square is 81 plus Y square minus 18Y plus X square. Here we have 81 on both sides of equation number 2, so 81 will get cancelled, and we will add 18R to this equation, equation number 2, and we will get that R square equals to 18R minus 18Y plus X square plus Y square. Here we will take 18 as a common factor out of those two expressions, and we will get that R square equals to, so we took 18 as a common factor, so inside the brackets we have R minus Y plus X square plus Y square So here we will subtract r square and y square from this equation, equation number 2, and we will get that according to equation number 2, r square minus x square minus y square is equal to 18 times r minus y. This is equation number 2. So in the next step we will draw perpendicular from point C to BE. So those two angles are equal to 90 degrees. Here in quadrilateral, we define the touching point between the perpendicular from point C and BE is point Q. So in quadrilateral QESF, we have three right angles. Therefore, the fourth angle must be equal also to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So quadrilateral QESF has four right angles, therefore quadrilateral QESF is a rectangle. I'll repeat again. Quadrilateral QESF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to QE. CF equals to QE. But CF equals to 1 unit. It is the radius of the smallest circle. So we can write here that CF equals to 1 unit. And from this equation, we will derive that QE also equals to 1 unit. QE equals to 1 unit. So we can write here that QE equals to 1 unit. And we will join point C and B together by a straight line. Here, those two triangles have an external line between them. They are touching each other at this point. Therefore, the distance between their centers, whenever you have an external line between two circles, then the distance between the centers of those two circles will be equal to the sum of the lengths of their radiuses. That is to say, the length of the radius of this circle is equal to 9 units, the length of the radius of the smallest circle is equal to 1 unit, and the sum of 9 plus 1 is 10. So CB equals to 10 units. And what is the value of QB? QB, as you can see here, QB or BQ, BQ is equal to BE minus QE. BQ is equal to BE minus QE. I repeat again. BQ equals to BE minus QE. So BQ equals to BE equals to 9 units and QE equals to 1 unit. So BQ equals to 9 minus 1 is 8. So BQ equals to 8 units and CB equals to 10 units. And if you focus on the right triangle, triangle BQC, in the right triangle, triangle BQC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here in the right triangle, triangle BQC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here the hypotenuse is BC, so the square of the hypotenuse is BC squared, and BC squared must be equal to BQ squared plus QC squared. I'll repeat again. According to the Pythagoras theorem, in the right triangle, triangle BQC, BC squared equals to BQ squared plus QC squared. BC equals to 10 units, so BC squared is 10 squared, 10 squared is 100, and it equals to BQ squared. BQ equals to 8 units. We already found out that BQ is equal to 8 units, so BQ squared will be equal to 64, because 8 squared is 64, plus QC squared. So we found out that 100 equals to 64 plus QC squared. We subtract 64 from this equation and we get that QC squared equals to 100 minus 64 is 36. We will take a root out of this equation and we will get that QC is equal to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6. Here QC equals to 6 units. And we know that quadrilateral QEFC has 3 right angles. Therefore, the fourth angle here it has 1, 2, 3 right angles. So the fourth angle must be also equal to the right angle. So quadrilateral QECF has 4 right angles. Therefore, quadrilateral QECF, quadrilateral QCEF is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, QC must be equal to EF, QC must be equal to EF, but we just right now found out that QC equals to 6 units. QC equals to 6 units. So from this equation, 6 equals to QC equals to EF, we will derive that EF also equals to 6 units. So we can write here that EF equals to 6 units. In the next step, we will join points. We will draw perpendicular from point C to OM. So this angle equals to 90 degrees. And this angle will be also equal to 90 degrees. We'll define the touching point between the perpendicular from point C to OM as U. And here quadrilateral UC FM as 1, 2, 3 right angles. Any quadrilateral that has 3 right angles, the fourth angle must be also equal to a right angle. Therefore, quadrilateral UCMF has 4 right angles. That is to say, quadrilateral UCMF is a rectangle quadrilateral UCMF is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to UM, CF equals to UM, but CF equals to 1 unit. It is the radius of the smallest circle. So from this equation, CF equals to UM equals to 1, we will derive that UM also equals to 1 unit. So here we can write down that UM equals to 1 unit, and here quadrilateral UMEQ has 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. So quadrilateral UMQE, this quadrilateral UMQE has 4 right angles. Therefore, quadrilateral UMQE is a rectangle and repeat again, quadrilateral UMQE is a rectangle because it has 4 right angles, and we know that the opposite sides of a rectangle are equal to each other. That is to say, ME equals to QU, ME is equal to QU, according to the rule that the opposite sides of a rectangle are equal to each other. M equals to QU, but we have already found, according to our definition, ME equals to X. ME equals to X. From this equation, we will derive that QU also equals to X. QU also equals to X. Therefore, UC is equal to X plus 6. UC equals to X plus 6. What is the value of OU? The value of OU in the value of line segment OU, the value of line segment OU will be equal to OM minus UM. OM minus UM. Again, OU equals to OM minus UM. Okay, OU equals to OM minus UM. But here, OM equals to Y according to our definition. And UM, we already found out that UM equals to 1. So in conclusion, we found out that OU equals to Y minus 1. And we will join points O and C together by a straight line. We'll join points O and C together by a straight line. What is the value of OC? The value of OC, O is the center of the biggest circle. That is to say, the radius of the biggest circle is equal to capital R. C is the radius of the smallest circle, and the radius of the smallest circle equals to 1 unit. The smallest circle and the biggest circle has an internal length between them at this point. They are touching each other at this point. Therefore, the distance between their centers, will be equal to the difference between the lengths of their radiuses. That is to say, it will be equal to capital R minus 1. Capital R minus 1. So we actually found out that OC equals to R minus 1. In the next step, we will focus on the right triangle OUC. I will copy the triangle in a new page, and we will implement the Pythagoras theorem on the right triangle OUC. Okay? Here, this is the right triangle OUC. I'll copy it in a new page and we'll implement the Pythagoras theorem on this right triangle. So, triangle OUC will So we will implement the Pythagoras theorem on this green right triangle OUC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here, in the right triangle OUC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC squared equals to OU squared plus UC squared. OC squared is R minus 1 squared. It equals to OU squared, that is Y minus 1 squared, plus UC squared. UC squared is x plus 6 squared. Here we will open the brackets on both sides of this equation number 3, and we will get that R minus 1 squared is R squared plus 1 minus 2R equals to Y minus 1 square. Y minus 1 square is Y square plus 1 minus 2Y plus x plus 6 square is x square plus 36 plus 12x. Here we have 1 on both sides of equation number 3, so 1 will get cancelled. We will add 2R to this equation, and we will get that R squared equals to 2R minus 2Y plus 36 plus 12x plus x squared plus y squared. We'll subtract x squared and y squared from this equation number 3. And we will get that according to equation number 3, r squared minus x squared minus y squared equals to, here we will take 2 as a common factor out of those two expressions. So 2r minus 2y, it will be equal to 2 times r minus y plus 36 plus 12x. So according to equation number 3, r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. And according to equation number 2, we have already found out that r squared minus x squared minus y squared equals to 18 times r minus y. And according to equation number 1, we found out that r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. Here we will compare equation number 1 to equation number 2. R squared minus x squared minus y squared according to equation number 1 must be equal to r squared minus x squared minus y squared according to equation number 2. In this way we will get equation number 4 that states that 8 times r minus y plus 144 minus 24x must be equal to 18 times r minus y. Here we'll subtract 8 times r minus y from this equation, equation number 4, and we will get that 144 minus 24x equals to 10 times r minus y. Here we will divide this equation, equation number 4, by 10, and we will get that r minus y according to equation number 4 is equal to 144 minus 24x over 10. Here we will divide both the numerator and the denominator of this on this side of equation number 4 by 2, and we will get that 144 over 2 is 72, minus 24x over 2 is minus 12x, and 10 over 2 is 5. So in conclusion, we found out that according to equation number 4, r minus y is equal to 72 minus 12x over 5. Likewise, we will compare equation number 2. So we got that r minus y equals to 72 minus 12x over x. Likewise, we will compare equation number 2 to equation number 3. And we will get that equation number 5 that states that 18 times r minus y must be equal to 2 times r minus y plus 36 plus 12x So here we will subtract 2 times r minus y from this equation, equation number 5, and we will get that 16 times r minus y is equal to 36 plus 12x. So here we'll divide this equation, equation number 5, by 16, and we will get that according to equation number 5, r minus y will be equal to 36 plus 12x over 16. Here we will divide both the numerator and the denominator by 4, and we will get that according to equation number 5, r minus y is equal to 36 over 4 is 9, 12x over 4 is 3x, and 16 over 4 is 4. So we found out that according to equation number 5, r minus y equals to 9 plus 3x. We will compare equation number 4 to equation number 5, that is to say r minus y according to equation number 4 must be equal to r minus y according to equation number 5. In this way we'll create equation number 6 that states that 9 plus 3x over 4 equals to 72 minus 12x over 5. Here we'll cross multiply this equation number 6, and we'll get that according to equation number 6, 5 times 9 plus 3x equals to 4 times 72 minus 12x. Here we will open the bracket, so here according to equation number 6, 5 times 9 is 45, plus 5 times 3x is 15x, equals to 4 times 72 is 288, 2 times minus 12x is minus 48x, here we will add to this equation 48x plus 15x is 63x, and here we subtract 45 from this equation, so 288 minus 45 is equals to 243. Here we will divide this equation by 9. So here 63 over 9 is 7x. 7x equals to 27. I'll check it here. 27, 243 over 9 is 27. So we got that 7x equals to 27. We will divide this equation by 7, and we will get that according to equation number 6, x equals to 27 over 7. And we have equation number 5 that states, according to equation number 5, r minus y is equal to 9 plus 3x over 4, and we've already found out that x equals to 27 over 7, so we will put the value of x inside equation number 5, and we will get that according to equation number 5, r minus y is equal to 9 plus 3x, and x equals to 27 over 7, so it is 3 times 27 over 7 divided by 4. So here we have according to equation number 5, r minus y equals to 3 times 27 is 81, so it is 81 over 7. Here we will multiply 9 by 7, and then we will divide it by 7, and we will get 63 plus 81 over 7 over 4. 63 plus 81 is 144. 144 over 4 times 7 is 28. So we got that r minus y equals to 144 over 28, Here we will divide both the numerator and the denominator on this side of the equation by 4, and we will get that r minus y according to equation number 5 is equal to 144 over 4 is 36, 28 over 4 is 7. So in conclusion, we found out that r minus x is equal to 36 over 7, while x equals to 27 over 7. Here, according to equation number 2, according to equation number 2, r squared minus y squared minus x squared equals to 18 times r minus y. R squared minus y squared equals to r plus y times r minus y. According to the algebraic identity that a plus a squared minus b squared equals to a plus b times a minus b, so it's, here it will be equal to r plus y times r minus y, that equals to x squared plus 18 times r minus y. Here we will substitute r minus y by 27 over 7, and we will substitute x by 20, we will substitute r minus y by 36 over 7, and we will substitute x by 27 over 7, and we will get that according to equation number 2, r plus y times r minus y, so r minus y is 36 over 7, that equals to x squared. X is 27 over 7 times 27 over 7 plus 18 times r minus y. R minus y is 36 over 7. So here we multiply this equation, equation number 2, by 7, and we will get that according to equation number 2, r plus y times 36 equals to 27 times 27 over 7 plus 18 times 36 So here we will divide equation number 2 by 9, and we will get that 36 over 9 is 4, so here we will have 4 times r plus y equals to 27 over 9 is 3, so it's 3 times 27 over 7 plus 18 over 9 is 2, and 2 times 36 is 72. Here we'll multiply 72 by 7 in order to have a common factor with this expression, and we will get that 4 times r plus y equals to 3 times 27 is 81 over 7, and 72 times 7 is 504, all divided by 7. Here we will divide this equation by 4, and we will get that according to equation number 2, first of all, 81 plus 504 is 585 divided by 7, and we divided this equation by 4, so it is 4 times 7. So r plus y equals to 585 over 4 times 7. That is to say, according to equation number 2, r plus y is equal to 585 over 27. 4 times 7 is 28. And we have already found out that according to equation number 5, r minus y is equal to 36 over 7. So here we will multiply both the numerator and the denominator by 4, and we will get that r minus y is equal to 36 times 4 is 144 over 7 times 4 is 28. So r minus y equals to 144 over 28. So we will add equation number 2 to equation number 5. Equation number 2 is r plus y that equals to 585 over 28, and equation number 5 is r minus y equals to 144 over 28. So we will add equation number 2 to equation number 5, and we get that r plus r is 2r, y minus y is 0, so we get that 2r equals to 585 plus 144 over 28. So here we actually got 2r equals to 585 plus 144 is 729 over 28. Here we will divide this equation by 2, and we will get that r equals to 729 over 56. So the radius of the biggest circle equals to 729 over 66 over 56, or it equals to 13.018 units. Okay, here and check it here. Here 729 over 56, so it is 13.018 units. So the radius of the biggest circle is equal to either 729 over 56, or you can also present it as 13.018 units. Okay, that is the answer to the question. In the next step, I will summarize the lecture. Actually, we wanted to find out the radius of the biggest circle, that is to say, the radius of this circle that contains 4 other small circles, and we know that the radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, and the radius of the smallest circle is equal to 1 unit. And we want to find out the radius of the biggest circle that contains those 3 small circles. So first of all, I presented to you 2 new theorems. The first theorem is external lunge. 2 circles can interact, they can touch each other in 2 different ways. The first type of tangent, or the first type of touching between 2 circles is the external lunge, when the 2 circles are touching each other externally. Here, point S is the touching point between those 2 circles, and is the point of tangency between those 2 circles, and the distance between the centers of these 2 circles, that is to say MO, equals to capital R plus small r. As you can see here, MO equals to capital R plus small r. Okay, and we also have the second type of tangency between 2 circles. When the 2 circles touch each other internally, then it is defined as internal lunge, and the distance between the radiuses, that is to say the distance between their centers, that is to say MO, will be equal to capital R minus small r. Why? Because OS equals to capital R, SM equals to small r, so OS minus SM equals to MO, that is to say MO equals to capital R minus small r. Okay? So in conclusion, whenever 2 circles are touching each other, we have 2 options. If they are touching each other externally, then it is defined as external lunge, and the distance between the centers will be equal to the sum of the lengths of their radiuses. In this case, it will be equal to capital R plus small r, and while when they touch each other internally, then the distance between their centers, will be equal to the difference between the lengths of their radiuses. In this case, it's capital R minus small r. Okay, then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So here, the radius AD is drawn to the point of tangency, that is to say it is drawn to point D, that is the point of tangency of this tangent with the circle. Therefore, the tangent will be perpendicular to the radius AD, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, here, the radius BE is drawn to the point of tangency, that is to say it is drawn to point E, that is the point of tangency of the tangent with this circle. Therefore, the tangent will be perpendicular to the radius BE, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And the same thing is true for the smallest circle. this angle will be equal to 90 degrees, this angle will be also equal to 90 degrees. And in the next step, we actually draw perpendicular from point A to BE. So this angle equals to 90 degrees and this angle also equals to 90 degrees. And we define the touching point between the perpendicular from point A and BE as point P. And here, quadrilateral APDE, here quadrilateral APDE has 3 right angles, 1, 2, 3, and the sum of 3 right angles is 270 degrees, plus the size of the fourth angle must be equal in total to 360 degrees. So we subtracted 270 degrees from this equation, and we found out that angle DAP equals to 360 degrees minus 270 degrees is 90 degrees. So here angle DAP, this angle equals to 90 degrees. So therefore, quadrilateral DAPE is a rectangle because it has 4 right angles, and we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to PE, but we know that AD equals to 4 units. It is the radius of this circle. So from this equation, 4 equals to AD equals to PE, we will derive that PE also equals to 4 units. So here PE equals to 4 units also. Likewise, in triangle ASDM, this triangle, so here we actually have in triangle ASDM we have 1, 2, 3 right angles, and if we repeat on the same process, we will conclude that the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles to 360 degrees. Therefore, quadrilateral ASDM is a rectangle. Okay, quadrilateral ASDM is a rectangle, and if we do the same analysis on the all other quadrilaterals, we will arrive to the conclusion that they are all rectangles. Why? Because all of them have 3 right angles, and any quadrilateral that has 3 right angles, the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles to 360 degrees. Therefore, all the quadrilaterals inside in this drawing are rectangles. Okay, so I will not repeat on the same process again, because we will find out that in any quadrilateral that we look for, we will find out that they have 3 right angles, and the fourth angle must be equal to 360 degrees in order to complete the sum of the angles to 360 degrees. Therefore, the quadrilateral has 4 right angles, and any quadrilateral that has 4 right angles, it is a rectangle. And so that is to say all the quadrilaterals in this drawing are rectangles. And we know that the opposite sides of a rectangle are equal to each other. Okay? So here AD equals to OM, AD equals to 4, so OM will be also equal to 4, OM equals to SP because the opposite sides of quadrilateral are equal to each other, so if OM equals to 4, then E also will be equal to 4. Then, so we know that PE equals to 4 units, and BE is the radius of this circle, that is to say it equals to 9 units, so BP is equals to BE minus PE, BP equals to BE minus PE, that is to say BP equals to BE that is 9 units minus PE that is 4 units, so BE equals to 9 minus 4, that is to say BP equals to 5 units, here BP equals to 5 units, and here the value of ABE, it is actually the distance between those two circles that have an external length between them. Therefore, the distance between the centers of those two circles will be equal to the sum of the lengths of the radiuses. The length of this radius is 4 units, the length of this radius is 9 units, and 9 plus 4 is 13, so AB equals to 13. We found out that BP equals to 5, so in the right angle triangle ABP, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say AB squared equals to BP squared plus AP squared. AB equals to 13, so AB squared is 13 squared. 13 squared is 169. BP is 5, so BP squared is 5 squared. 5 squared is 25. So we found out that 169 equals to 25 plus AP squared. We subtracted 25 from this equation, and we got that 144 equals to AP squared. We took a root out of this equation, and we got that AP equals to the square root of 144, and the square root of 144 is 12. So we found out that AP equals to 12 units, and triangle APDE is a rectangle. Triangle APDE is a rectangle. Here, triangle APDE this triangle is a rectangle, therefore the opposite sides of this rectangle are equal to each other, that is to say AP equals to DE, but we already found out that AP equals to 12 units, so DE will be also equal to 12 units, and we also know that dm, what is the value of dm? If DE equals to 12 units and ME equals to X according to our definition, then dm will be equal to DE minus ME, that is to say it will be equal to 12 minus X. and in rectangle ADMO, ADMS, the opposite sides are equal to each other, that is to say DM equals to AS. DM equals to AS, but we have already found out that DM equals to 12 minus x, so from this equation we will derive that AS also equals to 12 minus x. So here AS also equals to 12 minus x. Here in rectangle MSPE, we know that ME equals to x, therefore SB will be also equal to x, according to the rule that the opposite sides of a rectangle are equal to each other. We defined OM as y, and what is the value of OS? OS equals to OM minus SM. Again, OS equals to OM minus SM. But OM equals to y according to our definition. MS equals to 4. So OS equals to y minus 4. Here OS equals to y minus 4. And we already found out that AS equals to 12 minus x. What is the value of AO? The radius of this circle is equal to 4 units, and the radius of the bigger circle is capital R. Those two circles have an internal length between them in this point. Therefore, the distance between the centers of those two circles will be equal to the difference between the lengths of their radiuses, that is to say it will be equal to R minus 4. So in the right triangle AOS, we implemented the Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say R plus 1 square equals to y minus 4 square plus 12 minus x square. We found out that according to equation number 1, after we developed this equation, we found out that r square minus x square minus y square equals to 12 times r minus y plus 144 minus 24x. Okay, then from point O we draw perpendicular to BE, so this angle equals 90 degrees and this angle will be equal to 90 degrees. We define the touching point between the perpendicular from point O to BE as point T. We focus on the right triangle, triangle OBT. Here, triangle OSPT is a rectangle, and the opposite sides of a rectangle are equal to each other. So SP equals to OT. SP equals to X, so OT will be also equal to X. And what is the value of BT? BT equals to BE minus TE. Okay, here BT equals to BE minus TE. BE equals to 9. TE equals to Y by Y because the opposite sides of rectangle SPEM are equal to each other, that is to say here OM is equal to TE, but OM equals to Y according to our definition, therefore TE will be also equal to Y. So TE equals to Y, again BT equals to BE minus TE, BE equals to 9, T equals to Y, so in conclusion we found out that BT equals to 9 minus Y, and here OT equals to X because of the fact that the opposite sides of rectangle OSPT are equal to each other, so if SP equals to X, then OT will be also equal to X. So OT equals to x, BT equals to 9 minus y, and what is the value of OB? OB, O is the radius of the biggest circle, and B is the radius of this circle, and those two circles have an internal length between them at this point. Therefore, the distance between the centers of these circles, that is to say OB, will be equal to the difference between the lengths of their radiuses, that is to say it will be equal to r minus 9. So I draw triangle OBT in a new page, and we implemented the Pythagoras theorem on this triangle OBT. So here we get that r minus 9 squared is equal to 9 minus y squared plus x squared. We developed the equation number 2, and we found out that r squared minus x squared minus y squared equals to 18 times r minus y. Then we know that quadrilateral QESP. So here we actually, from point C, we do perpendicular to BE. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. So actually quadrilateral QSEF has 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. That is to say, quadrilateral QECF is a rectangle. Okay, quadrilateral QECF is a rectangle, and the opposite sides of rectangle are equal to each other. That is to say, CF must be equal to QE, but CF is equal to 1 unit. It is the radius of the smallest circle. So from this equation, 1 equals to CF equals to QE. We will derive that QE also equals to 1 unit. Here QE equals to 1 unit. And what is the value of BQ? BQ equals to BE minus QE. Okay, BQ equals to BE minus QE, but BE is the radius of this circle, that is to say it equals to 9 units. QE, we already found out that QE equals to 1. So in conclusion, we found out that BQ equals to 9 minus 1, that is to say BQ equals to 8 units, and we already found out that CB equals to 1 unit. Okay, here CB, actually CB here is equal to B is the center of this circle, that is radius is 9 units, and C is the center of this circle, that is radius is 1 unit, and those two circles have an external length between them. Therefore, the distance between their centers will be equal to the sum of the lengths of their radiuses, that is to say it will be equal to 9 plus 1, that is to say CB equals to 10 units. So CB equals to 10 units, BQ equals to 8 units. So in triangle BQC, this triangle BQC, according to the right angle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say BC square equals to BQ square plus QC square. BC equals to 10, so BC square is 10 square, 10 square is 100. BQ equals to 8, so BQ square is 8 square, 8 square is 64, so 64 plus QC square. Here we subtracted 64 from this equation, and we got that QC square equals to 100 minus 64 is 36. We took a root out of this equation and found out that QC equals to the square root of 36. The square root of 36 is 6. Okay, then actually we know that quadrilateral QCEF here we drew perpendicular from point C to OM. So this angle equals to 90 degrees and this angle also equals to 90 degrees. So quadrilateral UMCF, but before that, actually quadrilateral QCEF is a rectangle. Why? Because it has one, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. That is to say, quadrilateral QCEF has 4 right angles, and quadrilateral that has 4 right angles is a rectangle. So quadrilateral QCEF is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, QC is equal to EF. QC is equal to EF, but we already found out that QC equals to 6. So from this equation, 6 equals to QC equals to EF, we will derive that that EF also equals to 6 units. Okay. Then from point C we draw perpendicular to OM. So this angle equals to 90 degrees and this angle equals to 90 degrees. We define the touching point between the perpendicular from point C to OM as point U. So actually UCFM has 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 360 degrees. So quadrilateral UMCF has 4 right angles. Therefore, quadrilateral UCMF is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, UM is equal to CF. Okay, UM equals to CF, but CF equals to 1 unit. From this equation, 1 equals to CF equals to UM, we will conclude that UM also equals to 1 units. So here UM equals to 1 units. Okay? And we know that quadrilateral UMQE, quadrilateral UMQE is a rectangle. Why? Because it has here 1, 2, 3, 4 right angles, so it is a rectangle, and the opposite sides of rectangle are equal to each other. That is to say, ME equals to QU. Here ME equals to QU, but ME equals to X, according to our definition. So from this equation, X equals to ME equals to QU, we derive that QU also equals to X. And then we focused on the right triangle OCU. On this right triangle OCU, what is the value of OU? OU equals to OM minus UM. Again, OU equals to OM minus UM, but OM equals to Y, according to our definition. UM equals to 1, so OU equals to Y minus 1, and what is the value of UC? UC equals to x plus 6. And what is the value of OC? OC is the distance between the biggest circle and the smallest circle. The biggest circle and the smallest circle have an internal length between them at this point. Therefore, the distance between their centers will be equal to the difference between the lengths of their radiuses. That is to say, it will be equal to capital R minus 1. So OC equals to capital R minus 1. So here we focused on the right triangle OUC, and we implemented the Pythagorean theorem on this right triangle, triangle OUC. On this right triangle, we concluded that OU equals to y minus 1, OC equals to R minus 1, and UC equals to x plus 6. So according to the Pythagoras theorem, R minus 1 square equals to y minus 1 square plus x plus 6 square. We developed equation number 3 and we got that R square minus x square minus y square equals to 2 times R minus y plus 36 plus 12x. Then we wrote down the 3 equations in at this page. This is equation number 3, this is equation number 2, and this is equation number 1. And we created equation number 4 that says that R square minus x square minus y square according to equation number 1 must be equal to R square minus x square minus y square according to equation number 2. This is equation number 4. We developed equation number 4 and we got to the expression that R minus y equals to 72 minus 12x over 5. So according to equation number 4, R minus y equals to 72 minus 2x over 5. Then we created equation number 5 that states that R square minus x square minus y square according to equation number 2 must be equal to R square minus x square minus y square according to equation number 3. So this was equation number 5. And according to equation number 5, we got that R minus y equals to 9 plus 3x over 4. And then we created equation number 6 that states that R minus y according to equation number 4 must be equal to R minus y according to equation number 5. And from equation number 5, we found out that x equals to 27 over 7. And then we put the value of x inside equation number 5. Equation number 5 states that R minus y equals to 9 plus 3x over 4. So we substituted x by 27 over 7 because x equals to 27 over 7. And we found out that R minus y according to equation number 5 is equal to 36 over 7. This is the value of R minus y according to equation number 5, but the value of x, we have already found out that it is equal to 27 over 7. And then we wrote down equation number 2. According to equation number 2, R square minus y square minus x square equals to 18 times R minus y. Here R square minus y square, according to the algebraic identity that a square minus b square equals to a plus b times a minus b, R square minus y square is R plus y times R minus y, and it equals to x square plus 18 times R minus y. Here we substituted R minus y by 36 over 7, and we substituted x by 27 over 7, and we got to the equation that r plus y is equal to 585 over 28. This is according to equation number 2. While according to equation number 5, we already found out that r minus y equals to 36 over 7. So here we added equation number 5 to equation number 2. This is equation number 2, this is equation number 5, and then we added them together. R plus r is 2r, y minus y is 0. So we got here that 2r equals to 585 plus 144 over 28. So in conclusion, we found out that 2 times the radius of the biggest circle equals to 729 over 28. We divided this equation by 2, and we got that the radius of the biggest circle equals either to 729 over 56, or you can represent it as 13.018. I repeat again, the radius of the biggest circle equals either to 729 over 56, or you can represent it as 13.018 units. Okay? Thank you very much.